Today, I'm going to talk about building permissions into design modeling. This topic may sound a bit abstract at first, but specifically, I'd like to talk about a set of design patterns and best practices that can enable engineers to define and implement permissions for social network apps like Facebook, Instagram, and others. This permission framework has been widely used as meta for many products and internal tools as well, and has shown improvements in reliability and efficiency of permission checks in production. Here's the agenda today. It's pretty straightforward. I'll talk about why do we need such a framework, what's the problem I'm addressing, what are the common challenges when designing such a framework, how do we address those challenges in the framework, and what would be the main learnings from this talk. Cool. First, the problems. First, before talking about permissions, we understand what's the scope of the permission. And before joining Facebook privacy team, I've been working at the Facebook product team for many years, building user-facing features. And for user-facing features, there are a lot of actions that can happen on the app. You can see each of these kind of button is considered an action. Like, can I message this user, edit this post, change this setting, that setting, all those settings, or like create a chat. All of these are considered actions. Action is just a unit of activity that the user can perform on the app. And for every action, there should be a permission behind that to determine if the user can really see this action and perform that action. So that's, and you can see there are all those actions, and each one, if we require permission to safeguard and protect each one, there are all those permissions. When the app becomes complicated, the permission gets complicated. And that's why I think we need a permission framework to manage all those permissions, make it easy for engineers, and make it easy for users. Before jumping into the solutions, I'd like to share some common challenges we find that when people developing such a permission framework. The first one is complicated if-else statements. If I ask someone here to implement similar logic like this today, here, most people will just use the if-else statement to implement. It is very intuitive, very natural to implement permission like this. However, the logic is like, can the user delete this message? People will just implement, for example, if the user is the author of the message, they can delete it, otherwise they can't. So this kind of logic is very naturally can be expressed as an if-else statement. It works perfectly well when the logic is simple. However, when the logic is more complicated, when the feature has more exceptions, such logic, such if-else statements become very difficult. You can see there are some nested statements. The logic can become very long, and it makes engineers too hard to understand logic and debug the logic. Oh, by the way, all the code examples here are just made up. It's super code. So that's one of the problems. When we want to use this this kind of if-else statement to express the logic for permission. The second challenge is about inconsistent logic. Regarding permissions, we want the permission to be uniform across all platforms. When people check the permission, they get the same result. But it's easy because we developed features in multiple platforms like Android, iOS, web. Sometimes the logic is duplicated across platforms. When there's a new update on one platform, it may not be picked up in the other platform. We want the permission to be forward compatible, which means there's app releases, and when we just implement the permission on the hard coding on the clients, when there's a new release of the clients, it updates the new logic. However, those new updates won't be applied to the old versions. We also want the permission to be consistent across platforms, across call paths between, for example, UI and server. the problem is like, for example, when the user see there's an action to perform on the app, when they click on it, it throws exception because it does not accept by the server. This is not something we want. Like we want what can be seen on the UI side can be done on the server. And last challenge I found is like inefficient such evaluation. Like permission evaluation could take significant cost. And if the condition are not tracked carefully, and engineers, when they use it, they may not think of it carefully. This is a very good example, but just you can see we pay the cost of a load video player, but when the user probably doesn't even have permission to play the video. This kind of like code situation can cause all the fetch data or do like unnecessary computation if they are not checking correctly. So that's why I think we need a permission frame to try to address all those challenges to make those like to make the framework design like fit by design. The specifics of the framework is probably built on top of like Meta internal framework, so it's not very like the details is not very helpful. However, I think there are some key components from the framework that is very like generalizable and can be like reusable as well. So the first component is a rule engine pattern. Rule engine pattern is a design pattern that uses a set of predefined rules to determine the behavior of software. Each permission can have like corresponding policy class, and each policy class contains a set of rules. And each rule is just a piece of business logic. And the rule engine can evaluate the set of rules to determine allow or deny decision. You can see that previously, if we implement the permission logic in like if else allow deny rule, it can convert it to like policy class with a set of rules. This makes there are a few advantages of this kind of like a new abstraction and encapsulation. One is more flexible because the rules can be composed to represent complete logic. Like the one you've seen before about a super long and nasty if estimate could be like converted into such like a list of rules instead. We use delegation and composition to express complete logic. This is also using a rule to encapsulate the permission logic is also like more maintainable and readable because every rule has its name in itself. When people scan through it, it's just very easy to understand what's going on instead of reading into the details of each condition in the permission logic. It is also more reusable. Like, I mean, if there are multiple policies, we can just reuse the same rules again, because each one is a block of logic, and you can just share it across multiple policies. And it's also like more optimizable. Because of this abstraction, we can use an engine. It's called a rule engine to change the way those rules are computed, are evaluated. Different rule engine can be selected to achieve the most efficient evaluation result. I mean, most efficient evaluation without changing the result. It could be, we could try to, normally it should just run it in serial, but we can also try to run it in parallel or some like smart algorithm to shuffle the order of the rules. So make sure to always use the least cost rule at first, which can be most decisive. But the idea of the rule engine is just like, it changes the computation of the rule to try to find the most efficient evaluation, but it doesn't change the final result. And that's something we can improve the evaluation. When we define the rules, we're not thinking about the specific order, but if we have a rule engine, they can optimize the evaluation order itself. The second key component of a permission framework is the permission schema. Similar to data schema, permission schema defines the way a permission is organized and its relationship to data entities. In this example, you have like schema here, and we define some like data there, like the field is a description. It's it stores the description of a chat channel, like the string. So that's usually how we define a data schema. Then we can add permission there to define what the permission that you can take on this entity. It helps centralize all the permission in one places. So when people ask, what's the all permission we can do on this data object? It's very easy. It's just right there. The list is right there. Very easy to enumerate all the permissions for this entity. Also, it helps people to think about permission when they design data model. So when starting off the project to design this feature, it's not about how this data model, how this fields, how those relationships between entities. It's also about the permissions, like the relationship between permission and the entity is right in the schema. It helps people to design that, model that, without going into the implementation details about the permission. There are some more probably advanced usage of the permission schema. So when we design a permission schema, there are some learning from that. It's we want the permission to be designed has the right granularity to be future-proof. So we don't want the permission to cover all. There can be multiple actions. We see before there are multiple settings, multiple actions a user can do, and for permission, we don't want the permission to cover all of them. Instead, we try to define permission for each action, but use some other features like delegation or share rules to share the logic, to implement the permission without duplication. So in this example, there's a new field called name. We want to understand who can see the name. The logic is similar to who can see the description. So we just use delegate attributes to indicate, these permissions are actually the same, but there are two permissions. The last part is our API integration. API integration ensures permission enforced. The last thing we want to see is that we define permission simply correctly, but the engineer didn't use it somehow, forgot to add it. So with a close integration with the API, we make sure the permission is always called when user read a button or click on a button. There are multiple approaches to achieve this, depending on the language you're using. It can be use a decorator or a split between public and internal API. So when people call the public, always call the public API, and the permission is built in there. And it can enforce bad behavior. Like you see, we can prevent overfetching data or do unnecessary computation by always enforcing to run the permission first. Okay, that's all. Let's put them all together. The three key components of the permission framework. The first one is rule engine pattern, which makes permission to be flexible, scalable, and more easy to debug. There's the permission schema, which helps design permission modeling, makes permission organized and centralized managed in one place. And last is API integration, which makes permission enforced and consistent. That's all the talk. Thank you, everyone, and open to questions.